안녕하세요. 통계적 학습 이론 수강생 이동규입니다. Let's start announcing the project progress. The papers I have chosen are Causal Discovery with Reinforcement Learning on the Causality topic and Sample Selection for Fair and Robust Training on the Fairness topic. In each paper, the necessary background knowledge is first explained. After defining the problem and task, I analyze the algorithm. Afterwards, I will explain the plan until the final presentation. In a directed acyclic graph, a node is each component and an arrow between them is a link indicating a direct causal relationship. Causal inference is to infer the effect of a certain policy, inferring a causal relationship from observable data. At this time, as we learned in class, correlation does not mean causation. The following is an explanation of reinforcement learning, a type of machine learning in which an agent interacts with the environment through actions in a given state. In this process, the learning process to find out the policy to maximize the reward is called reinforcement learning. There are various and deep researches on reinforcement learning, but the algorithm required in this paper is the following actor-critic algorithm. Rather than the agent taking action and receiving rewards, the critic evaluates the state that changes as the actor takes action and finds the optimal policy. The next thing you need to know is the encoder and decoder structure. The encoder literally encodes the input sequence into a single vector, and the decoder turns the encoded vector back into an output sequence. Through this process, the entire flow of sequences can be known, but information loss occurs. For this purpose, an attention mechanism is used when the encoder outputs. It refers to the input sequence and concentrates on the association. In the self-attention method used in this paper, when receiving an input sequence, other parts of this sequence are also focused, and the correlation of each element can be determined. The paper presents the following problems. The score-based methods traditionally used in the process of finding the DAG uses a local heuristic and a predefined score function. Although it is possible to find a DAG with infinite data and an existing score function, in practice, the performance is poor due to finite data and violation of assumptions. Taking this into account, the paper that proposes a new method is the Causal Discovery with Reinforcement Learning that I selected. The main idea is to use the RL method to find a DAG. The RL agent determines where to search based on the information given by the learned policy. It is meaningful in that it presents a structure for causal discovery using RL. The overall RL architecture. Observed data as input and creates a graph through encoder-decoder model. Whether the generated graph is appropriate is determined through the reward function, which will be explained later. And the optimal graph is found by repeating this process. This structure was applied to various data sets and its feasibility was verified later. Each variable xi is associated with a node I in a d-node DAG. In X, the observed value of xi is obtained as a function of fairness of the graph and the noise ni. The observed data x was sampled according to the above model from an unknown DAG. The purpose of causal discovery is to infer a causal relationship DAG G using X. A neural net NN for graph generation. As described above, it takes observed data as input, uses the encoder and decoder model, and outputs a graph adjacency matrix. Self-attention-based encoders can find causal relationships between variables. An adjacency matrix is created using a single-layer decoder having the following values Gij. And this is our design. First, we use a function predefined as a score function. The first term of this score function is the low likelihood objective, and the second term adds penalty on the number of edges in the graph G. The following defines the penalty term considering acyclicity. Define a reward function that includes both terms above, including the indicator function. The reward function consists of two penalty terms and a score function. It is an algorithm for causal discovery. I use expectation of reward as the learning objective function using the actor credit algorithm. The psi obtained as a result of training is a parameter of the neural net used for graph generation. As a result, the DAG is updated and new reward is calculated again. So far, the analysis of the core algorithm of this paper has been completed, and afterwards I plan to analyze the experiments presented in the paper until final. I want to analyze the dataset used and the evaluation method and the results. In addition, since this paper has open source, I plan to implement it and compare it directly with the results of the paper. Finally, I plan to discuss the purpose and results of the paper, as well as its pros and cons. The first topic above was the presentation of the causality topic. And next is a sample selection for fair and robust training on the fairness topic. I will present in the same order as the previous presentations. Fairness is about learning an unbiased model. The purpose is to remove bias in the data. And sensitive attributes is a term related to fairness and is a factor that affects bias. Robustness is about learning from corrupted data. The purpose is to compensate for noise in the data. Fairness and robustness are closely related to each other because if you care about one side, the performance of the other side very poor. And another background knowledge, ITLM is a popular robust training method. This is SOTA algorithm, and a clean sample is obtained using the loss as shown below. It has more accurate model performance even with high noise, but has poor performance in fairness. There are two factors for comparing the performance of fairness in this paper and many fairness analysis. First, equalized odds goal is to obtain the same accuracy between sensitive groups conditioned on the true labels. And the below equation is we learned in class. And demographic parity score is to satisfied when the sensitive groups have the same positive prediction ratio. The paper states that fairness and robustness are closely related to each other. However, there is no stable solution that both have good performance. So, sample selection for fair and robust training. proposes a sample selection-based algorithm for fair and robust training. It shows good results in practice by modifying only the sampling step without changing the training algorithm or data. First, add fairness constraints in the clean selection we saw earlier, ITLM. To do so, it is assumed that fairness constraints have an upper bound, and constraints can be expressed in the following way. In equation 2, the first term is the constraint of the previous ITLM algorithm, and the second is the constraint related to fairness in this paper. Although the sample selection optimization on the previous slide uses inequality constraints, leeway to sample size due to inequality constraints for fairness. In training section, since only the sampling step is modified, the learning process uses the existing weighted ERM method. In the process of generating the fairness constraint described above, the sampling ratio of sensitive attributes is adjusted using a batch. For each batch selection, compute fairness of the intermediate model. Then the sample size of sensitive groups is adjusted in the next batch. This algorithm shows the clean and fair sample selection process. This problem can be viewed identically to the classic multiple dimensional knapsack problem. So, sampling can be done with time complexity n log n through the following process. And this following process is well-known process. So this whole process is skipped. This is a full learning algorithm using the preceding sampling method. Set as using greedy-based sampling selection in previous slide, and update theta according to the mini-batch via stochastic gradient descent. A mini-batch selection can be considered as an unbiased estimator of the ERM. So far, the analysis of the core algorithm of the paper has been completed. Afterwards, I plan to study for the mathematical proof of the method presented in the paper until final presentation. Also, since this paper analyzes the experimental result in detail, so I plan to analyze the process and result. Finally, I plan to discuss the purpose and result of the paper, as well as its pros and cons also. This is the end of my presentation about project progress, and thank you for listening.